All right, Martin, show us what you got.
Okay, so this is an Apple III with its case off. I just put some decorates. I'm going to boot this floppy. That's my Hackfest.
That's pretty cool.
So
Let's explain it for the lay people.
Yeah, explain what we're seeing here.
Let me explain to you what you're seeing. So the Apple III was able to emulate a 48K Apple II Plus. Only 48K. They put specific hardware in there to keep you out of the rest of the memory in the machine, and to keep you out of all the nice fancy graphics modes in the Apple III, to keep you away from the 2 megahertz CPU, etc., etc., etc. But they give you a disk that'll boot from Apple III to Apple II mode. So I used the disassembler I built 2 years ago on the Apple III to boot trace that disk with some help of a classic KansasFest scenario where I bounced from Tony to Stavros, back to Tony, to Stavros, to Steve. I ended up with a magic PDF file that was an internal marketing document that talked about the horrible disaster that Satan mode would be, and gave me clues on how to activate it. So, long story short, I figured out how to activate Satan mode. What it means is, I'm running an Apple II ROM, I'm running AppleSoft Basic, I'm running DOS 3.3, but I have access to all the weirdness of the Apple III, including colored text on the screen. So if I run the color text demo, we can go just change the background and foreground color of any character on the screen. You can change the font of the text screen. You can access all 256K without bank switching through a brilliant scheme that they put in the Apple III. You can do a couple of other demos on this disk. I will show you very quickly. You can turn the CPU speed up, and the Apple II beep sounds funny when you do that.
Can it do double high res?
It can do double high res, and it can do a double high res monochrome mode that the Apple IIe cannot do, which is cool. Now, the Apple III has many horrible things about it, but one good thing is they built hardware to make it beep. And if you trigger that hardware at the same time as the software beep, you get old beep, new beep, both at the same time. That's my demo.
Thank you very much.
Wonderful. Question. What would it take to retrofit this mode onto like a cracked copy of Earhart so that you could just boot Earhart on an Apple III and have the 128K and so on available?
It would take a lot of disk space because the Apple II ROM has to be loaded from disk first. Other than that, no problem.
Okay, this is my first assembly game that I've ever written, so it's just basically text. These are the rules. You move with the arrow keys or WASD. It's a text line that goes across the screen and it attacks you. It's given by a zing sound. If you're on the path that the line is attacking, there's a buzzing noise and you get 25 points per cycle, which is every time it loops through the main loop of the program, which is dangerous. If you're not, which is safer, you get only 1 point. You die if you're hit by the front of the line. You die if you're on the line and it gets to the other screen, it'll erase really quickly, and you can die from that. Space to pause, delete is end. After 25,000 points, it begins to very slowly speed up after 5,000 points. Your dot, which you are moving around to get out of the way, is displayed randomly, so sometimes you can't see it after 5,000 points. And after 10,000 points, only the endpoints of the lines are displayed. So that's what it is. And if you watch the score when I'm on top of the line and you can hear the buzzing, you can see the score increase greatly.
So you're trying to get on the line without getting hit by the front of the line.
Yes, and it'll display your score and the high score, so that if I play again, it'll keep the high score. So let's say I died there, we retain the high score.
Right. So what environment did you write it in?
I wrote it in Notepad, and then I copied it and pasted it into the emulator and assembled it.
So you so you pasted it into the mini assembler in the monitor, or how did you assemble it?
It's
Did you type in hex codes for each?
Or is it in
it's
Merlin, or?
It's Edasm. It was
Okay.
Yeah.
Gotcha. All right, great. Any questions, Jim?
Very old school.
Very cool. All right, all right, Jeremy, show us what you got.
So every year I struggle to come up with an idea what to do, and I generally resort to looking at my iPhone and seeing what games I have on there and what I can try to base a game on. And so I saw Chameleon Run, it's a game on iOS, and I made something I call Color Go for the Apple II. You do need a color monitor to play it. So the idea is your character, you're on some kind of floor, the floor is a certain color, you have to be the same color as the floor. You can jump, you can double jump, use the closed Apple to jump. You can change colors by pressing any key, spacebar is kind of convenient. You can't touch a solid white floor, or you can't touch a white floor, it can only be violet or green. And when the floor goes solid, that's the last segment, and that's the end of that level. So let's start. Here we go.
The animation.
Oh, see, I got a bug. Right away. It went right through that. It's not...
Take two.
Yeah. Try to do it without the double jump. There we go. So this is just level 1. No change in colors, just some gaps you have to jump. And that's the end of that level. And that's the success sound. So this is the next level. Now we have a change in colors. So I'll press space. There we go. Oh, I should show some of the different ways you can die. So if I just change colors right there, that's death. If I just let them fall, or touch that white, I guess. This isn't, yeah, so that white, you can't touch that. If you can fall, jump. Oh. Okay. You can also do little jumps. How long you hold option down is important. How high you jump. Oh. But you see, yeah, fell right through. Let me just quit this, and I'll show you. I've got 6 levels. Let me show you the last one. I'll just hard code it to launch the last level, so I don't have to try to beat them all. I think all the ones I've shown you so far. Let's see, that was the 3rd level. Actually, let me show you the 4th level. I'll just skip that one. It's not just flat. You can have multiple hierarchies. You can have overlapping floors. So you can have floors at different levels. What's interesting is you can hit your head. So you can double jump. That bug got me that time. Let me try show you what I mean. You can double jump, and as soon as you touch a floor, you can double jump again. So I can kind of bounce around underneath and pop through. That's the same bug, it's just in a different direction.
Excellent.
So you can have multiple ways of winning, right? I could have gone down there, or I can try it up here.
What's it written in?
but mostly assembly. There's a little bit of C on the beginning and end, just start up and shut down. This one's the last level. Oh, let's see if I can finish this one. It just goes up and up. And if you get to the top of the screen, you bounce off the top of the screen.
Oh, no!
But that's it. Yeah, that's basically it.
Excellent. Very cool. Thank you very much.
That's the game.
Questions? All right, Russ, show us what you got.
So mine's kind of a late entry. Somebody I was talking to at lunch convinced me to enter, and so I hadn't written any AppleSoft or 6502 assembly for probably 25 years. So I thought I'd take it simple and go with something that I could do in AppleSoft that would, couldn't possibly be too slow for AppleSoft. So I did the game of 2048. Let's see, 2048. And it turns out AppleSoft still manages to be too slow for it to be usable. So if I hit a key right now, that's the amount of time it takes to do one move, which is a little unbearable. So I decided last night to dust off the 6502 assembly. And because I wasn't sure I'd be able to do the whole thing from scratch again, I made an even slower version that just stored all variables in the hex 300 region of memory and peeked and poked them out. And then I was able to, so here's that version.
Definitely slower.
Yeah, it seems even slower than I remember. But anyway, so, and then I could start kind of writing individual functions or subroutines in assembler. And so let's see, I have some auxiliary routines I will load there, and then I will run the faster version, which now actually runs at real speed and is usable. So here I have it signal a win when you hit a 64, just so the demo doesn't take forever. You usually do that just by kind of mashing keys around monkey style. There we go. And it lets you continue playing after that. So that's
Very
it.
nice.
What were examples of some of the routines that you recoded in assembly?
I first did the one that actually packs things, because its time was almost evenly split between, well, that was probably the slowest part, and actually repainting the screen was really slow too. And so in the assembly version, I just override just the text. I have a lookup table of all the numbers pre-rendered and just paste them into place to make it faster. I did it all in the mini assembler, and then just went back and patched all the addresses that needed to, because I don't know. Again, I didn't have an assembler set up,
That's
and
why it's there.
wasn't sure how long that would take.
That's how
to do,
Nasir
so-
wrote SpaceX. Yeah.
But yeah, I started vaguely remembering there's all these tools for things like renumbering in AppleSoft. I have some places where I'm using every number, and my assembly code is spaced out on sort of half-page boundaries so that I can at least have some chance of remembering things, and then a big text file to write down all the labels.
Okay,
So
awesome.
That's it.
Thank you very much.
So in the modern world, for the chess games, you have the separation between the user interface and the engine. And also the user interface are even able to organize tournament between the engines. And I was wondering if we could do the same for the Apple II. And so I took one of the games I played was with Start, which is Sargon II. And so I debugged it on your Apple Win to see how it was sending moves and receiving moves. Okay. And now that I have configured, I will do it on another disk, which is I think where the chess is. So the idea is to replace the input routine of the chess game and read the moves from the serial image you can find on Azimuth. Okay, so I'm executing my code, and it will already send. What did I forget? It should already send a few comments. I know it wouldn't work for the demo.
So where are we expecting to find action?
Actually,
here?
Sargon should start here.
I see, okay. What you typed looked plausible to me. It looked right, but I don't know what it's supposed to do.
Okay, demo effect. It should.
Does it
Faster than that.
Does it depend on getting anything over
No,
the
not
serial?
yet. No.
Okay.
Okay. Do you want to? You can feel free to play with it some more. All right, Rob, what do you got for us?
So Jeremy Rand's kind of like raised the bar on what the Hackfest is about, and Kevin Savitt's kind of raised the bar on what Atari people need to do for Hackfest. So this is some high-res stuff. And in full disclosure, this is part of. I had to do some work ahead of time because I didn't know assembly language. I got a high-res screen. I didn't know any of that stuff. And of course, I used your sprite generator tool.
Mm-hmm.
So this is a game.
Those little Ataris.
So this is a clone of the game Amidar.
Oh, yeah.
And it's like super slow because they haven't optimized any of it at all.
No, it's good though.
Yeah, the super slow isn't actually the word I would have used.
Yes.
This looks pretty respectable to me.
Yeah. This
So I wanted to do. I want to do a game in the style of like, 1980s, like NASA or something like that. And so the point counts. You only get like 1 point for every block you color.
So what is this written in?
It's assembly language.
All assembly?
Yep.
What environment?
Let's see. This is AppleWin, and gotta say I don't really like the AppleWin's debugger, and I was using it a lot. It kind of sucks. But the assembler is actually, it's an Atari assembler actually, so don't take points away from that. But it produces 6502, and I wrote a little script using Peter Ferry's it's a standard delivery bootloader, and I hacked it so that's when initially loaded it was flipping screens on the high-res screen. His stuff will happily load sectors and wherever, and so I just hacked it so it would flip screens as it was loading.
So during that process, it was actually loading the content of the game.
Yeah.
Nice.
I see.
So theoretically it starts over, but I have a bug that. Yeah. So I haven't tracked that one down yet.
Excellent. That's fantastic. Thank you very much. Okay, Alain, show us what you got.
So on this side, we launched Sargon. I did my small program on it already inputted. It has input 3 keys to start the game, choose the color on the level. Now, I'm sorry, I'm going to use Apple Win as the one that needs enough. So I will launch Apple Win on this side. Verify that he starts the serial port, and I will basically do the exact same commands, except that I will change a byte to tell this guy that he's playing white.
Okay.
So, yeah, so it's the only difference. And now,
Yeah, I was just gonna ask what was the difference with. Yeah, okay.
and
Nice.
basically that's for the visual part, that's it. So getting the moves is quite easy because you just have to get the characters one by one. Sending the moves required a bit more debugging because the same output routine is used in Sargon for different things. Displaying its own move or the error messages. And you also have to reformat the castle because castle is output as 0-0-0 and input as E1, G1, E8, C8, and like that. Yeah, so that's for the today. I intend to try to hack other chess games and maybe. But
So how did you find the patch to make? Like what was your process in finding that?
I put breakpoints in Apple Win in the basic routines. So for the input, it was, as I said, very easy. I just had to detour the routine. And then I had to add additional filter because yesterday I had from time to time I had issue with the serial port, so I filter out the characters which I don't know. And for the output, I did basically the same, but I had to work 3 levels up the stack because the same routine was used. For example, if I enter an invalid move, it will display invalid move. And so I wanted just to detour the part where it sends the move. And I had also to find out the color and the castle comes from another buffer because it's hard-coded strings instead of being generated. But,
Okay.
yeah.
That's fantastic. Questions? All right, thank you very much. All right, Alex, show us what you got.
Okay, I just got this 2GS and I wanted to do something for Hackfest, so I had other plans originally, but turns out the 816 is more different than I expected. So I made something else, and here it is.
What is it called?
It's called Particle.
Okay.
And it generates random numbers and generates particles or little stars on a 320 by 160 super high-res screen. And it will write. It operates properly with GSOS, so it's a little slow, but
So you hit a
it
quick,
does-
you
it does
hit a
return
quick
to
key and it
desktop
goes back to the
properly.
desktop. Very nice. And what environment did you write this in? Is it
I used Merlin, and I had just the one disk drive, so it
Merlin
was
and
a
one
painful
floppy disk?
process.
That's fantastic. Thank you very much. Questions, you guys? No? All right, thank you. All right, Charles, show us what you got.
This was my first attempt at a Hackfest. I took my script for converting a disk image into a PNG image and sort of reversed it by editing the image in an image editor and converting it into a DSK, and then converting that back into this, and so you get Hello World in bits on the disk. What was supposed to happen was take this and make a physical floppy of it, but because there's no synchronization in the disk 2, it just ended up as a garbled spirograph image. So instead I went to Inform and started making a text adventure, and decided to turn things around a little bit. So instead of being eaten by a Grue, in this you are a Grue, and the darkness is complete and you can't see anything. So everything else is done with your other 4 senses. And the goal of the game, if you don't know about Grues in Infocom games, is to eat the adventurer. And so you're using your other 4 senses to eat the adventurer eventually. If you make too much noise, he either kills you or runs away. If he runs away, you starve to death because you don't have an adventurer to eat, that kind of thing. And Kevin and Carrington both helped me with the playtesting and gave me some tips, and I've added a few Easter eggs and some other fun stuff in there. There's not a lot to see because it is a text adventure game, but it is pitch black. You are a Grue, and you start out in your lair, wedged comfortably, relaxing in the cold comfort of a stone crevice. The walls worn smooth by years of occupation, that kind of thing. Was there anything else you'd like me to show you on that?
Do you want to play a little bit? Show us some.
Sure. So. No luminous fungi or glowing worms venture here with their harsh, painful light. Also, your eyes are closed. So let's open eyes. That didn't help much. It is still pitch black. So we can listen. If I can type properly. You listen to the lair. It is blissfully quiet here, deep in the crevice you call home. Just outside, you barely hear the scuff of a boot on stone doing its best not to be heard. So that gives you the clue there's something outside. So I'm going to go outside. It is pitch dark and you can't see a thing. The darkness is absolute. Your eyes are useless here. So again, we can listen. Dripping water echoes from the distance deeper in the cavern. You can hear the heavy breathing of a frightened adventurer here. Occasionally, the adventurer bumps into a boulder or wall while helplessly stumbling around in the dark. So we can try to eat the adventurer. In your hunger and desperation, you lurch for the adventurer, emitting a terrifying howl. You trip in a humiliatingly un-Grue-like way. Your final thoughts just before the adventurer's cold metal sword plunges into your unprotected back are regrets. Your impatience has done you in. You should have stayed hidden. You have died. It is pitch black. You are an ex-Grue. So that's one playthrough, and you can attest to how many steps it takes to actually win the game.
It was super fun.
It's very short now. It's very short now, but the plan is to flesh it out now that I know a little bit more about Inform.
Is this your first Inform project?
This is my first Inform project.
Very cool.
Yeah. Excellent.
Questions? No? All right.
Thank you.
Charles.
Thanks.
All right, Kevin, show us what you got.
So this is my first hardware project I've done for the Apple II. I got these buttons from Amazon, and
Hold them in front of the screen.
okay, but it's over here. I got these buttons from Amazon, and these big old pretty buttons, and I wired them to the paddle inputs of the Apple II using this fantastic and professional wiring job.
Very nice.
You can see that I've done here. So the Apple thinks that each of these is paddle 0, 1, 2, and 3. And you're going to have to go wide for this. And then I wrote a Simon program. So Simon says, press a big colorful button to play. You do that. And it thinks for a second, and it tells you to match the pattern. So it said purple, so I'm going to hit purple. It wants me to do purple-orange. And it goes like that. And then say I goof it now. And it tells me how many I got right. And you press the button play again, and all the music is in the key of C.
Nice. What's it written in?
It's written in Apple Soft Basic.
Oh, basic. Nice.
Yep.
It's not very long.
And the buttons are acting as joystick inputs?
The voice, yes, it thinks they're paddle inputs, and basically, when you press a button, the paddle input goes to 0, and otherwise it's non-zero.
Okay, so it's using the analog inputs rather than the
Yes, using
digital.
analog inputs, not the digital
okay.
buttons. Yeah.
Cool. Questions?
Interesting choice. That's cool.
All right, thank you, Kevin.